Hello, hi everyone. Welcome to the Student Brand. So this is Siva sir. Today I'm going to discuss about current electricity, current. So here today we are going to discuss about current electricity, electric current. So now we'll discuss electric current, electric current, current electricity. Now here you can observe the rate of flow of charge is called electric current. The rate of flow of charge is called electric current. So I equal to dq by dt is flow of charge or delta q by delta t, delta q by delta t. Okay. Okay. So the flow of charge. So I'm considering here like this. Instantaneous current. I equal to q by t. Q by t is average current. Average current. So this instantaneous current. Instantaneous current. Instantaneous current is I. And average current. Average current. Average current I equal to q by t. Okay. So flow of charge we can say. Flow of charge. So what is the meaning of instantaneous current and average current? Instantaneous current is nothing but the current at particular instant. So we can take in kinematics. So velocity of the object at particular. So if the object is moving with very fast. Okay. So at the particular instant, what is the speed of the object? At a particular instant, what is the velocity of the object? At particular instant, what is the acceleration of the object? At that particular instant, so at the time of so particular second, so what is the velocity, speed and acceleration? We will take instantaneous. Here also instantaneous current. At that particular time, how much charge is flowing? How much charge is flowing? By that we can able to say, so instantaneous current. Coming to the average current, the total net charge flowing through the conductor per time, per unit time. Okay, so we can take like that. So I equal to delta q by delta t, I equal to q by t. So the flow of charge can be obtained by multiplying constant current and time. So the flow of charge can be obtained by multiplying constant current with respect to time. And coming to the flow of charge can be obtained. So if it is current is the function of time, the current is function of time by integrating t initial and t final. So we can take I into dt. And coming to the third one, so flow of charge can be obtained by area under the graph of IT. By area under the graph of IT. Okay. So like this we can take. So flow of charge can be obtained by multiplying a constant current with respect to time. And the flow of charge can be obtained if the time is current is a function of time, then I equal to I into dt. And coming to the flow of charge can be obtained by the area under the graph I into t. That is nothing but IT graph. Okay, so this is about charge, right? Now, so current and mass based on the magnitude and direction. Based on the magnitude and direction, current can be divided into two parts. Based on the magnitude and direction, current can be divided into two parts. Okay, so magnitude and direction. Magnitude and direction. And direction. Based on magnitude and direction, current can be divided into two parts. So one is DC, another one is AC. One is DC, another one is AC. First one I am taking. First one is DC, second one is AC. So direct current. Direct current we can take the example cell, battery, DC dynamo, DC dynamo. And coming to the alternative current, example AC dynamo, AC dynamo. So here you can observe direct current. Here magnitude and direction does not change with respect to time. So here magnitude and current direction will changes. Magnitude and direction of current changes. Okay. So that is about DC and AC. If the charge is flowing in a circular path with a frequency f, then current I equal to Q into F. Q into F. Okay. So that's enough. Now we will discuss about drift velocity. Drift velocity. Drift velocity and relaxation time. Drift velocity and relaxation time we will discuss. Drift velocity and relaxation time. Okay, so drift velocity. And relaxation time. Okay. So when the current is flowing, so I am taking here, current is flowing, so electrical field will be there. At the same time, electrons are moving opposite to the electrical field. So that is about drift velocity. Drift velocity. So when electrons are moving in the electrical field, the electrons are moving in the electrical field, it experience force. It experience force. Yes or no? So F equal to QE or E. Now, so we know F equal to MA. So MA equal to Q into E. So that is A equal to Q into E by M. Okay. So what is the drift velocity? What is the meaning of drift velocity? Drift velocity is nothing but, so actually if you are taking the conductor like this, so electrons are start moving in the conductor. So here electrons are start moving like this. Okay, so suppose I'm taking like this. Electrons are moving in the conductor. So we can take charges, so positive charges, so electrons I'm considering here. So this electron is going to hit another electron, this electron is going to hit another electron, that electron is going to hit another electron. So what happens when electrons are moving in the conductor? So there is a collision because they are moving in a closed path. They are moving in a closed path. Then what happens when it is moving? One electron will hit another electron, that electron will hit another electron, that electron will hit another electron, then keep on collision is taking place, keep on bombardment takes place, keep on collision takes place. Okay, so that time what happens? Velocity of the electron changes when it is moving. So it is moving, initially it is moving with some velocity, after collision they are moving with some velocity, after collision one more velocity, like that keep on velocity changes. At the same time, the overall, the average velocity of an electron also change. Okay, so like one electron, another electron after collision, so the velocity changes, right? Yes, sir. So the average velocity of an electron is known as drift velocity. Understood or not? So one electron is moving with suppose 1 meter per second or 2 meter per second. So another electron 5 meter per second, another electron 6 meter per second, another electron like this. Suppose just example you are taking. So after colliding another electron, so that electron will be with a different velocity. After collision again, so the average velocity of an electron moving in the conductor is called drift velocity. And one more thing, relaxation time. Relaxation time. What is a relaxation time? So normally after one collision, so electron hit one each other. After going to another electron and hitting, so the time gap between one collision to another collision, the time gap between one collision to another collision. Okay, so the average time between two successive collisions. That two successive collisions. We can't take one collision here. So after 10th collision or 20th collision, 30th collision, we should not take. We have to take immediately one collision, after that immediately next one. So the average time gap between the two successive collisions is known as relaxation time. So that is about drift velocity and relaxation time. Drift velocity and relaxation time. I hope it is very clear, right? Yes. Now next one, current and drift velocity. Current and drift velocity. Current and drift velocity. Next one. Current and drift velocity. Okay, so now I am considering like this. Current and drift velocity. So conductor is there, cylindrical conductor. So area of the cross section I am taking, this area of the cross section A, and here also area of the cross section I am taking like this, same area of the cross section. This is the length I am taking, length. And here, so anyway, current is moving, electrical field will be there. So electrons are moving opposite to the electrical field. That's the drift velocity I am taking. Okay, and so time gap is there, time. So delta t I am taking, right? So delta t. Now delta t. So here you can observe velocity equal to L by T. Here drift velocity I am taking L by delta T. So L equal to Vd into delta T, the length of the conductor. So Vd into delta T. That is the length of the conductor. What about area? Sorry, volume. Volume is nothing but volume equal to length into area. Volume is the nothing but length into area. So volume equal to length into area. Length is nothing but Vd into delta T into A, area of the cross section. Now, number of electrons are present in the particular volume. Number of electrons present in the particular volume. So, number of electrons, I am writing number of electrons present in the particular volume, that is equal to, so N into Vd into delta T into A. So we know quantization of charge, Q equal to Ne. Okay. So N we already know, just E. So delta Q I am taking. So N is nothing but N Vd delta T into A into E. So we know current. What is the current? So current I equal to delta Q by delta T. Substitute the value N Vd delta T into A into E by delta T. So delta T get cancel, N Vd A into E. So that is current. I equal to N Vd A into E. No, current density equal to current density. Okay, current density J equal to I by A. So I equal to I we know, right? So what is the formula? N Vd A into E. So I equal to I N Vd A into E by A. So A got cancelled. So J equal to Ne Vd. So this is the formula for current density. J is the current density. Understood? Current density. So this is about current and drift velocity. Okay. So next we'll discuss about one more. That is resistance. Okay. So now we'll discuss about resistance. Resistance and temperature depends on resistance. Electromotive force and next. Resistors are connected in series and parallel after the Kirchhoff's laws. So Kirchhoff's two laws. We'll discuss. After that, we will discuss about grouping of cells. After that, we'll discuss about grouping of cells. Now I'll discuss about resistance and resistivity. Okay? Chalo then. Now, resistance and resistivity will discuss. Resistance is nothing but resistance, resistivity, resistance and resistivity. So, resistor is a device. So, resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current. Resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current. Resistance depends on length of the conductor. Resistance depends on area of the cross section. So R is directly proportional to L. R is inversely proportional to area of the cross section. R equal to rho into L by A. R equal to rho into L by A. So rho is the resistivity. Rho is the resistivity. Rho is the resistivity. So rho equal to RA by L. RA by L. Rho is the resistivity. RA by L. Right? Now you can observe here. So resistance and resistivity differences we'll discuss. Resistance and resistivity. Point number 1. R equal to rho into L by A. So rho equal to R by L. Second point is resistance depends on length of the conductor actually. So ohm and here ohm meter SI unit of resistivity. Here SI unit of resistance is ohm. SI unit of area is meter. SI unit of area is meter square. SI unit of length is meter. SI unit of area is meter square. So we can get ohm meter. So that is a SI unit of resistivity. Now third one. So resistance depends on temperature. And here also resistivity also depends on temperature. And here resistance depends on material of the conductor. Material. So resistivity also depends on material of the conductor. Material of the conductor. Here you can observe one thing. Resistance also depends on length of the conductor and area of the cross section. Resistance also depends on length of the conductor and area of the cross section. So you can observe here resistance, resistivity already you know that. Okay. So now we'll discuss about temperature dependence of resistance. Temperature dependence of resistance. Okay. So be ready for it. Now next we'll discuss about one more. Temperature dependence of resistance. Temperature dependence of resistance. Temperature dependence of resistance. So here, so R is directly proportional to L, R is inversely proportional to area of the cross section. R equal to rho into L by A. So here, when temperature increases, 2 points I'll discuss. Point number 1. So listen carefully. When temperature increases, immediately free electrons movement also increases. So free electrons are there in the conductor. Automatically their movement, okay, so they'll move with a greater amplitude. By that, at that instant time, so temporary resistance and resistivity decreases, conductivity increases. So once electrons start moving with a greater amplitude, what happens that time? So the electrons start bombarding or start hitting or start colliding with the another electrons. Okay, so with the rest of electrons, then what happens? So collision will takes place more frequently. Okay, it happens more randomly, more frequently, more randomly. Then what happens at that time? Electrons collisions takes place more than it's moving forward. So that time resistance and resistivity increases, conductivity decreases. So final conclusion is, when temperature increases, resistance and resistivity also increases. When temperature increases, automatically collision will takes place more frequently. It happens, randomly happens, because electrons are moving with a greater amplitude. Then by that we can understand resistance and resistivity also increases. Right? Yes. Now we can take, so R equal to a temperature T. Okay, so R is a temperature T. R naught is a temperature T naught. R naught is a temperature T naught. Rho is a T. Rho naught is temperature T naught. Okay, so now you can observe the formula is R equal to R naught plus 1 plus alpha into T minus T naught. So what is alpha? Alpha is nothing but temperature coefficient of resistance. Alpha is nothing but temperature coefficient of resistance. So R equal to R naught plus R naught alpha T minus T naught, then so we can take R minus R naught equal to R naught alpha T minus T naught, then alpha equal to R minus R naught by R naught into T minus T naught is nothing but delta T. Okay, so even for resistance, this is resistance, coming resistivity also, rho minus rho naught by rho naught into delta T. Okay, so delta T I am taking now, delta T. I hope it is very clear to you all. Is it clear? Next one. So we are going to discuss about one more. So electromotive force. Electromotive force is nothing but so here you can observe. So cell I am connecting to the resistor. So resistor is like this. So positive term and negative term current is flowing. Okay. Now you can observe here current is flowing. So high potential, low potential, high potential, low potential. Positive charge will move from high potential to low potential. So whereas electrons will move from low potential to high potential. But so in the cell, you can observe in the cell. So in the cell, you can observe here in the cell. So positive charge should move from negative terminal to positive terminal. The influence that makes to move positive charge from negative terminal to positive terminal. The influence which makes the positive charge to move from negative terminal to positive terminal in the cell is called EMF, electromotive force. The work done by the battery on the charge, positive charge, to move from negative terminal to positive terminal, that is called EMF. So EMF is nothing but E equal to W by Q. Electromotive force. Electromotive force. The influence, the work done by the battery and positive charge to move from negative terminal to positive terminal in the cell, inside of this cell. Okay. So I hope it is very clear to you all. I hope it is very clear to all. So this is about electromotive force. And coming to the next one, resistors are connected in series combination and resistors are connected in parallel combination. Resistors are connected in series combination and resistors are connected in parallel combination. Resistors are connected in series combination and resistors are connected in parallel combination. Now we'll discuss that point. Here you can see resistors are connected in series combination. Resistors connected in series combination. Series combination. Resistors are connected in series combination. Now you can see so So current is same, Is equal to I1 equal to I2 equal to I3 equal to I. Current is same. But potential difference is different. Okay? Potential difference is different. So current is same, potential difference is different. So Vs equal to V1 plus V2 plus V3. V1 plus V2 plus V3. So IRs equal to IR1 plus IR2 plus IR3. So I am taking I common. IRs equal to I, if you are taking common, R1 plus R2 plus R3. So I get cancel, Rs equal to R1 plus R2 plus R3. So resistors are connected in series combination. If n number of resistors are connected in series combination, so Rs equal to Nr. If n number of resistors are connected in series combination, Rs equal to Nr. If resistors are connected in parallel combination, now you can observe here R1, R2, R3, potential difference V1, V2, V3. So entire the circuit current is same. Is equal to I1 equal to I2 equal to I3 equal to I. So I we are taking Vs equal to V1 plus V2 plus V3. IRs equal to IR1 plus IR2 plus IR3. I am taking common because I. So entire the circuit current is same. I get cancelled. Rs equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. So now we'll discuss about resistors are connected in parallel combination. Resistors are connected in parallel combination. Now you can see resistors are connected in parallel combination. R1, R2 and R3. So not in series, parallel combination. So resistors are connected in parallel combination. So here you can observe potential difference is same. So Vp equal to V1 equal to V2 equal to V3 equal to V, because so same potential difference across R1, R2, R3, but current is different. Current is different. So we can take, we know from Ohm's law V equal to IR, I equal to V by R, V equal to IR, I equal to V by R. So now we can take IP equal to I1 plus I2 plus I3. I1, IP equal to I1 plus I2 plus I3. So IP we can write V by RP. So from Ohm's law we can write V by RP. So V by RP equal to V by R1 plus V by R2 plus V by R3. So shall I take V common? 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3, because I am taking V common. So V I am taking common. 1 by RP equal to, okay, sorry, 1 by RP already I wrote here, 1 by R2 plus 1 by R3. So V will get cancelled. 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. 1 by RP equal to 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula. If n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, so that is 1 by Rp equal to n by R, n by R. So Rp equal to R by n. So this is a formula. This is a formula. I hope it is very clear. Just check once. If n number of resistors are connected in parallel combination, so 1 by Rp equal to n by R, Rp equal to R by n. You can observe here. So R1, R2, R3, three are connected in parallel combination, right? So potential difference is same. Current is different. IP equal to I1 plus I2 plus I3. V by Rp equal to V by R1 plus V by R2 plus V by R3. 1 by Rp equal to N by R. So Rp equal to R by N. Okay. So by that we can take V will get cancelled. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula. Resistors are connected in parallel combination. Right? Yes. So thank you so much for joining and attending and listening my class. So if you like the content, if you like the channel, if you like my explanation, do like, share and subscribe to Study India Brand. So thank you so much for joining and attending. So you can check in the community post. There is a class notes for CBSE Grade 10 Physics. So light reflection, diffraction, human in current world, electricity, magnetic effects of electric current. 4 chapters notes is available. You can check in the community post. You will get the link. So you can join to the WhatsApp channel. You can check the notes. So thank you so much. We'll see you in the next class. So tomorrow Sunday. So we'll be getting daily classes. Okay. So keep attending, keep joining, keep supporting me. Thank you so much.